Hello everyone, this is PM Chellapandi here. First of all, I would like to welcome you to my today's session. In this session, we are going to discuss about how to solve this problem, right? Okay, in the previous problem, we had our problem in terms of pi form. In this problem, we are having our values in terms of T form. Okay, depends on pi form and T form. It is type 1 and type 2. So here it is type 2. Let us see how to solve this type 2 problem, right? So before we dive into solving this problem, let's come here. Let's have a quick review about throughout this problem what we are going to do, right? So there will be 3 steps. In step 1, we are going to write what are the necessary formula, right, to solve this problem. In step 2, we are going to find out what are the necessary result that we can substitute in the formula, and at the end we can find out our Fourier series expansions. In step 3, we are going to substitute our results, right, in the general Fourier series formula. These are the things that we are going to do throughout this problem. Let us dive into solving this problem. Okay, here this is the given results. So for this results, we are going to find out what is the Fourier series expansions, right? So before that, first we need to check till what harmonic we have to expand our Fourier series. That is very important. So here it is second harmonic, right? As we had in the previous problem, here too we are having till the second harmonic we need to expand, right? Our Fourier series expansion. Okay, first, if your given results, given data is given in terms of T form, it is very easy to solve. So the first step you need to do is you have to convert this T form into pi form. It is very easy. You just replace T is equal to 2 pi. That is enough. Then automatically it will be converting into pi form. Once you converted your T form into pi form, then all the process is similar as we have seen in the previous case, right? Okay, so let us see how it works. So here T is equal to 2 pi. After simplification, it becomes pi 3, right? So after when you put T is equal to 2 pi, 2 and 6 can be cancelled, then it becomes pi by 3. Similarly, here after substituting T is equal to 2 pi, you will get it is 2 pi is divided by 3. Here you will get 2 will be cancelled, so it is pi. So here 2 into 2 pi, it is 4 pi. So therefore 4 pi is divided by 3. Here 5 into 2 pi, 2 and 6 can be cancelled. After simplification, it becomes 5 pi is divided by 3. Then it is 2 pi. So this is the first step that we need to do. After you converting your T form into pi form, then your next step is you need to check whether you're having same term in first and last data or not. So as we have the previous problem, here also we are having the same term in first and last term. So if you have such a thing, then what you have to do? You have to neglect this last term for tabulation, right? Okay, so after doing all these process, let us come to the formula construction, right? So this is general Fourier series formula. So here we are given to expand this general Fourier series formula in terms of second harmonic. So I just have expanded in terms of second harmonic, right? So after expanding, here our task is we need to find out what are the Fourier coefficients. So here what are the Fourier coefficients? It is A0, A1, A2, B1, B2. To find all these Fourier coefficients, we have separate formula that I have written here. By help of this formula, you can easily find out what is the value of Fourier coefficients, right? So to find the Fourier coefficients in this formula, we require a tabulation, okay, a tabular column where we are going to get all the required results. So as we have discussed in the previous problem, these are the required things, okay? These summation values that we require. To find these summation values, first we need to find out all these tabulation value. So it is very easy. I will explain only one square value. The remaining square value can be obtained in the same way, right? Okay. So here I want to check this one. Okay. Here what is the value of y? It is 1.30 into what is the value of cos x into cos bracket. You have to use the bracket. Then x value is pi by 3. Similarly, you have to substitute your x value for this y and the x, for this y and the x for all the process. In this way, you have to complete all the values. Okay. So you have to remember one more thing. So dear students, most of the students are doing the same mistake. The mistake is they are not converting their mode in the calculator in terms of radiant mode, right? So if you want to calculate anything in calculator for the value of pi, the first step is you need to convert it into the radiant form so that it will give the correct value, right? So it is very easy. You just press your mode 4 times. I think in some calculator it may get vary. So what you have to find out is you need to find out the radiant mode. When you press mode at some point of pressing, you will definitely get the radiant mode. For what number you have to press for radiant mode, you have to press according to your calculator. So it will be converted into radiant mode. You can check it in the display. It will be showing as R, right? So if you get such a display value, then it is converted. That's all, very simple. Okay. Now, so in this way, you have to construct all these tabulation. Now, at the end, you have to add all these results. So after you find all the required results in the tabulation, right? So let us come to substitute the results which you have found here in the formulas which already we have written in the step 1, right? So to find A naught, so already we have written the formula. So here it is summation y is divided by 6, divided by n. So n is number of outcomes in y-axis, right? So it is 6. Clear? So here summation y is nothing but the sum of these values are called the summation y. Okay, you have to add all these values. You have calculator. By help of calculator, it can be added easily, right? So at the end, this is our result. So I'm going to substitute this result in the formula of A naught. So, okay, after substituting, I get this result. After simplification, I get this result. In this way, you have to find out all other Fourier coefficients A1, A2, and B1, B2 by help of the formula, right? So at the end, you will get all these results. What is your final step? After finding the Fourier coefficients, you have to substitute that results in the general Fourier series formula, which we have expanded already in the step 1 till the second harmonic. Okay. After substituting all these results, so this is called our expected Fourier series expansion for this problem. Okay, so dear students, I hope you all have got a clear idea about how to solve this problem and how to expand this data in terms of Fourier series expansion. So thank you so much. I will meet you in the next video with a different problem. Thank you.